I mean, do you just take an instrument and plop it down and then get the data and know exactly what's happening?
I wish it was that simple. So yeah, we have the Met stations set up, and well, someone else before me set them up, and so what my job is I come and we have calibrated sensors that we bring in every 2 to 3 years. So I'll visit the site and I'll swap the sensor out, and then the data is logged into a data logger. And so while I visit, I swap out a storage module, bring the data back here, download the data, and I'll do a quick comb through to see that the instrument's working right. And if there's a problem, then I'll schedule another trip back out to the site to try to figure out what's wrong with it and replace it if necessary.
What's the calibration process?
The calibration process is where, for most of the manufactured ones, we will actually send it back to the manufacturer, and they'll run several tests on it and sign off that it's still operating to certain conditions. Most of the sensors here are tested to the very cold conditions, to negative 40 C and below. And so they'll come back to us, and then we'll install and swap them out.
So is there an error, percentage error that these instruments have?
Yeah,
and how do you deal with it?
It depends on the specific sensor and what that percentage is, and they're trying to minimize them as much as possible. But typical errors are, for some, especially the solar radiation sensors, are around 4%. And so that's part of what you're dealing with. It's just the nature of it. More expensive sensors will reduce that error generally, but for a deployment like this, where you have up to 14 stations, the standard is kind of moderately expensive sensors. They're still expensive, but you try to go with what's standard, so you compare your data to other people's data in other locations. So you try to balance getting the best data possible and being able to compare it to other data. So yeah, you have these errors, so you have to constrain your data within that error and be mindful of it when working with the data. There's also post-processing involved that I do after the data is collected. I'll go through the data, once initially to see if there's problems, but then I'll come through it for several more months. And
really looking at it by hand and
graphing it out, comparing it to other stations, flagging data that's wrong, and eliminating it from the final data set. And then so I'll go through it several times for each station, each parameter, and then flag, remove what's necessary, clean it up, and then apply any post-processing factors that go into it. There's different methods for analyzing data or for removing certain errors. And so we'll do that after the fact, after we collect the data, and we'll clean it up. So we still have the original data of what the instrument actually collected, but we also have this post-processed data, and so that's what eventually gets moved out.
Why can't you just write a computer program to do that post-processing?
Well, we do run macros, but there's things that you can never anticipate, so you definitely need the human eye to go over it. The post-processing is put, so the data, I look over the data, make sure that there's no problems, but I do move it through a large macro which combs it and filters out and actually flags things automatically that alerts me to certain things. So I'll have an idea if something's gone wrong or out of range, or if two parameters don't look right. I'll get a flag, and some of them are just warning flags, and some of them are like, this data is bad. So that definitely cuts down on the amount of time that I have to put in, but you definitely need a human eye on it to make sure that it's still coherent.
Yeah, did you hear that story about when they were collecting the ozone data? I guess the British.
Just recently, yeah, they found out the way they
calculate. Was there something recently? I was thinking about way back in between the 70s and the 80s.
There's something up that has come up again.
Oh yeah.
As what I understand, yeah, I heard about it a little about this season. That the way something is calculated isn't quite right, and so we're a little bit off on our predictions.
Oh.
I think it might be how the rate at which the ozone hole is shrinking. I know they're re-examining that whole rate after the past couple seasons of it being very large. Yeah, but yeah, so the idea is that you always keep your original data, and that's what you want to make sure that's available for people in the future, because if the method that you're applying to post-process your data is wrong, you want to be able to go back to that original data that was collected to see if you could apply a different method to it.
Oh, interesting. Yeah. And how often do people, like you and Matt were talking about today, how often do people come in and do experiments that kind of test the instruments?
Right.
Or question the instruments.
It's folks usually do it if a new instrument comes online, or if they want to switch to a new sensor. They'll usually do experiments to do a side-by-side comparison under different conditions to see what the errors are different. In our case, Matt has a really great instrument that is much more accurate than the sensors that we have out here. So we could measure things across a wider spectrum more accurately, and so we could compare the data that we have been collecting against this more accurate device and see how the data compare. And for the broad climate sense, the data that we're collecting is great, but for Matt's work, he's looking at very subtle changes and very subtle differences in the data. So it's the things that he's looking for. This device is great to be able to do those comparisons. So it's common until something becomes very widely known, and when the sensor is known inside out, then folks generally accept certain types of sensors as being standard. Yeah.
Cool. Well, that's really good. Is there something else that you think I missed, or?
I could never think of those. Whenever I get asked those questions, I could never think of them. I was like, I don't know.
I think that was good. I really like the energy balance explanation.